This question looks like it's going to be harder, but in fact, it's easier. Alright, so let's give this a go. Cos squared x, you'll remember that what this really means, this is just shorthand for this. Okay, that's what it really means. It's just kind of like, look, less brackets, same meaning. Let's just write it like this, okay? It's the whole thing that's being squared, not just that little term, the x there, which is what it might look like if you just wrote cos x squared. So I actually read that as cos squared x. Now, being that that's what it means on the left-hand side, we want to solve it in terms of a trig equation, right? So I'm going to need to get rid of that squared. So we'll take the square root of both sides. But when you have a square, take the square root of both sides, what happens to the right-hand side?
Plus or minus. You
get a plus or minus, don't you? Okay? The square root of 1 is just 1, and the square root of 2 is root 2. Okay? So there you go. Now, this looks like it's worse, but it's actually much better because in all of these examples we've just looked at, you have to pay attention to the sign. And you have to work out, okay, whereabouts am I, which values am I interested in? But now, you're just interested in all of them, okay? So rather than looking at just 2 quadrants, when you see a plus minus, you automatically know I'm going to get an answer out of all 4 quadrants, okay? What's the related angle? What's the basic angle you're going to get out of this? Yeah, me too. It's 45, isn't it? Right? Cos 45 is 1 on root 2, okay? So therefore, excuse me, I can go straight to writing my 4 answers, knowing that I have to look at 45 in the first quadrant, second quadrant, and third quadrant, and fourth quadrant, okay? Just to make it really instructive for you, I'm going to put an extra step in, which you don't have to put in, but it helps to think about this. The way you get the 4 answers, in case it's not clear yet, is you go from 0 forward, then you go from 180 backwards, 180 forwards, and 360 backwards. That's what gives you your 4 actual angles, okay? So your angles are going to be 45, 135, 225, 315. Yeah? Thumbs up? Yes?
If it's not a, what's it called, one of those perfect number thing, 45 thing?
Yep.
Do you just do it in the calculator?
Yes, and I'll give you an example in a second. Okay. 45. Exact values are what you're thinking of? Exact value? If it's not an exact value is what you're asking, and the answer is yes, you do it. Okay. I'll just tell that in a second.
I just went straight away. I was like, cos x is half is 30.
That's fine. That's fine.
And then I did all the 31.
There you go. Okay, now we're starting to add layers of complexity here. Okay, so let's have a go at this. Sine 2x equals a half. Sine 2x equals a half. And you may remember, slow down. You may remember from last year, and your exercise when you did the graphing on this, but what effect does this 2 have on our sine function?
Steeper.
That's right, it's steeper. I'll just wait till we're ready. Sine 2x. One way is to say it gets steeper. Probably a more accurate way to say it, because they're trig functions and they're periodic, is that it makes it more frequent. In fact, it makes it twice as frequent. And if I put in 3x there, it'll be 3 times as frequent, and so on. Okay. So again, are you sick of me banging on about this? I think your best way to approach this is by graphing the thing, right? Graph the thing. Okay. Here's what I'm going to do. What does this look like from 0 to 360? Instead of having one copy of the graph, I'm just going to have 2, right? It's going to happen twice. 1, 2. Done. Okay? So now, when I draw this line through, y equals a half, bam, surprise, surprise, you have not 2, but 4 solutions. 1, 2, 3, 4. Okay? So I'm going to go about this the way that I would have done it before, except there's just this slight difference, this 2x, okay? You may like to think about it as being that x is between 0 and 360, right? It's kind of as though 2x, remember when we were doing inequalities before? You've got 2 inequalities really here. You've got x is greater than 0 and x is less than 360, but we treat them all as one thing because we can do it all in one piece. If I've multiplied this by 2, right? Then to have the same thing on both sides, I have to multiply everything by 2, right? 2 times 0 is still 0. but this will be 720. Okay, does that make sense? So now when I start to write out my solutions, 2x is going to be equal to, for sine x equals a half, what's our base angle? It's our base angle. It's 30 degrees, right? So 30 degrees, and then my next one will be 150. And that's usually where I would stop, because between 0 and 360, that's all the solutions you've got, yeah? But because I've got 2x there, right, I can actually go further, right? So what would my next solution after 150 be? It'll be this plus 360. And then it'll be this also plus 360, right? Which is, what, 510, right? There you go. Okay. That's 2x equals, right? Except I just want answers for x, not answers for 2x. Okay, so I divide everything through by 2, which gives me 15, 75, 195, and 255. Which were the 4 solutions that you can even see, they kind of make sense. Look how everything's kind of compressed, right? 15, 75, 195, 255, and there's 360 roughly where you would expect it.